All right, welcome. Today we are going to take a really clever little math puzzle and, use it to pull back the curtain on how great problem solvers think. The goal here isn't just about getting the right answer, it's about learning the right way to get there.
Okay, so let's jump right in. Here's the brain teaser. Imagine you've got all the numbers from 1 to 100. Now, if you go through and swap every single digit 6 for a digit 9, what happens to the total sum? How much does it change?
Now, before we even start crunching numbers, we gotta talk strategy. The biggest secret to tackling a problem that looks complicated is, well, it's to not solve the complicated problem at all. You break it down. You turn one big challenge into a couple of smaller, way more manageable ones.
So, we're going to approach this with a simple two-step plan. First, we need to know what we're starting with, right? We'll figure out the sum of all the numbers from 1 to 100. Then, for step 2, we're going to completely ignore that sum and just focus on calculating the difference caused by our 6 to 9 switch.
So, for step 1, we're going to pull a classic tool out of the toolbox. And to do that, we're actually going to borrow a trick from one of the greatest mathematicians who ever lived, the one and only Carl Gauss.
So the story goes that when Gauss was just a kid in school, his teacher told him to add up all the numbers to 100, probably just to keep him busy. But instead of doing it the hard way, 1 plus 2 is 3, plus 3 is 6, and so on, he spotted this beautiful little pattern. He started pairing numbers, the first with the last, the second with the second to last. You get the idea. And here's the genius part. Every single one of these pairs, 1 and 100, 2 and 99, 3 and 98, all the way to the middle, they all add up to the exact same number, 101. And since we have 100 numbers, that means we have exactly 50 of these perfect pairs.
And just like that, a really tedious problem becomes, well, simple. We just have 50 pairs, and each one is worth 101. So 50 times 101 gives us our grand total, 50/50. And boom, step 1 is done.
All right, let's get into the second part of our puzzle, which is figuring out the total change from all those 6s to 9s. And for this, we're going to need a different kind of systematic thinking, something called place value.
So to figure out the total change, we first have to answer a more basic question. Just how many 6s are we even dealing with? And we can't just guess here. We need a really organized way to make sure we count every single one of them.
This is where looking at place value is like a superpower. Let's break it down. First, how many times does 6 show up in the units place? Well, we have 6, 16, 26, all the way to 96. That's 10 times. Okay, now for the tens place. That's everything from 60 to 69. And yep, that's another 10 times. And you might notice the number 66 gets counted in both columns, which is exactly what we want, because it has a 6 in both places.
Okay, so there we have it. 10 6s in the unit spot, 10 6s in the 10 spot. That means the digit 6 appears a grand total of 20 times. Now we know exactly what we're working with.
So now that we've got our counts, we can finally calculate the exact change. This is where all that careful work breaking things down by place value really pays off.
Okay, let's start with the units place again. Every time a 6 in that column becomes a 9, the value of the number goes up by 3, right? From 6 to 9 is a jump of 3. Since that happens 10 times, that gives us a total change of 30. But now, look at the tens place. This is where the change is much bigger. When a 6 in the tens place becomes a 9, the value of that number jumps by 30. Just think about 61 turning into 91. That's a plus 30 change. And since that happens 10 times, that adds up to a whopping 300.
And now we just do the simple addition. We've got the 30 from our units place, we've got the 300 from our tens place, and that gives us our final answer. The total sum increases by exactly 330.
So you might be thinking, okay, that was a fun little mental workout, but so what? Why did we just walk through all of that? What's the bigger picture here? Well, it's because the exact thinking skills we just used are not just for math puzzles. They are universal tools for solving pretty much any complex problem. We deconstructed it, right? We broke it down. We used pattern recognition, just like Gauss did. And we used systematic analysis with the place value to make sure we didn't miss anything. And get this. This is exactly the kind of thinking that programmers and software engineers use every single day to build the apps and websites we use. It's not some kind of magic. It's just a methodical, creative way of solving problems. I mean, just take a look at this list. These are all famous programming challenges.
Every single one, from two-sum to the n-queens puzzle, relies on breaking things down and finding patterns. And look at that last one. There's literally a popular puzzle called Maximum 69 Number, which is all about, you guessed it, manipulating digits just like we did.
So what it all comes down to is this: mastering the process is so much more powerful than just memorizing one solution. The real takeaway here isn't the number 330. It's the framework, the repeatable method that you can now apply to your own challenges.
And that leaves us with one final thought. What's a challenge, big or small, in your work or your life right now that just feels totally overwhelming? What might happen if you stopped trying to solve it all at once and instead just focused on breaking it down first? That's something to think about.